Comparing covalent and ionic bonding. Ionic bonding. As you know, atoms lose or gain electrons to attain a complete outer shell of electrons. For the first 20 elements, except for hydrogen, the result is a stable octet in the outermost electron shell. Metals lose electrons, nonmetals gain electrons. When atoms lose electrons, they become positive ions. When atoms gain electrons, they become negative ions. The positive and negative ions are attracted to each other, forming ionic bonds. Ionic bonds are formed between metals and nonmetals. Let's take a look at how sodium forms an ionic bond with chlorine. If we take a look at sodium, we'll see that it has several paired electrons. In its innermost shell, it has one set of paired electrons, and in its next shell, it has 1, 2, 3, 4 sets of paired electrons. In its outermost shell, it has one single electron, no paired electrons. If we take a look at chlorine, we see that it has paired electrons in all of its inner shells, and it has 3 pairs of electrons in its outermost shell, but is missing another electron to pair up with this one. Not only that, but it lacks the stable octet, as it has 7 electrons instead of 8. So both of these atoms have unpaired electrons in their outermost electron shell. What happens, as you know, is that this one electron from the outermost shell of sodium is attracted to the chlorine nucleus, and it forms a pair with the unpaired electron in the chlorine outer shell. This gives chlorine a stable octet in its outer shell. But what it does for sodium is that it also gives it a stable octet, because this electron is no longer present, and the outermost electron shell now is this. So how do we show this? Well, here's our sodium atom lacking its electron that it's lost to chlorine, and here's chlorine having gained the electron from sodium. We want to show that sodium now has one less electron and chlorine has one more electron. So we use square brackets and we show the charge of the overall atom. Sodium has a charge of +1, remember, because it's lost an electron, but it still has got the same number of protons. Chlorine would be shown like this, because it's gained an electron. It has one more electron than the number of protons in its nucleus. Covalent bonding. When nonmetals react together, both atoms need to gain electrons to obtain a stable octet. The atoms are held together by shared pairs of electrons. The shared pair of electrons is a covalent bond, or it forms a covalent bond. Here's a hydrogen atom. Hydrogen atoms have only one electron. They actually don't get a stable octet. They're stable when they have 2 electrons in their innermost shell, because that's the only shell they have. Here's a nitrogen atom. Nitrogen atoms do need 8 electrons in their outermost shell. In this nitrogen atom, we have one set of electrons that are paired and 3 unpaired sets of electrons. Not really sets, individual electrons. Hydrogen has also got an unpaired electron in its outermost shell. When these atoms form a covalent compound, this is what happens. If we take a closer look, we see that hydrogen is sharing its electron with nitrogen, and nitrogen shares an electron with hydrogen. This alone would not fulfill the needs for nitrogen to have 8 electrons in its outer shell. It actually needs 2 more hydrogen atoms to share their electrons with it in order to appear to have, or so to speak, believed to have, 8 electrons in its outermost shell. Hydrogen, that is, each one of these hydrogen atoms, believes it has 2 electrons in its outermost shell, which gives it a complete outermost shell. So in a way, nitrogen is fulfilling the needs of hydrogen, and hydrogen is fulfilling the needs of nitrogen. In a covalent bond, the atoms, electrons, are not being transferred from one atom to another, rather they're being shared. We can also see that nitrogen still has a lone pair of electrons in its outermost shell. A shorter form way of showing covalent bonding is like this. Have a closer look at the examples on page 176 and 177.